first to our sponsor, Rick Van Gorsel, ID Quantique, who's going to give a 5-minute or so talk. And following that, I'll introduce this speaker. Rick, go ahead and take it away.
I hope that you see me now.
We can see your screen now.
Okay, good. And now you should see my screen and the presentation mode. Thank you, Don, and thanks the organizers for this wonderful meeting. It was wonderful last year in January, and I'm glad that you having it again, even though it's virtual. I'll give you a very short introduction to ID Quantique. And I wanted to talk about our advances in single photon detectors and electronics. I'll try to keep it short, within 5 minutes. We are a spin-off from University of Geneva, the group of applied physics, already back in 2001. That time, the people from the GAP, they wanted to, they saw an advantage of using quantum technology, quantum physics in quantum communication. And that's what we set out to do. In order to do that, we had to develop a lot of our own instrumentation because there was nothing out there in 2000. Started in 2001 with our first near-SPAD single photon detector and our quantum random number generator shipped. And since then, things have every year we have at least one product launch to keep ourselves going. And the last, like you see right now, is from 2015 and going to the future of 2025 for our quantum security business unit. And you can see that we wanted to launch a QRNG in a mobile in 2019. It has just been launched in May. And some other things have been actually advanced a little bit, like the quantum key distribution on satellite is a little earlier. So this is the last slide is only for our quantum safe business unit. And what I want to talk about is our quantum sensing, which got a big boost, literally, by our collaboration with Arianespace, which is the contractor for the European Space Agency, which decided that rather than using electricity to ignite the rockets, they want to do optics. And in order to do that, they need something to look at the integrity of their optical fiber system. And they chose to work with us because of our long history in being able to having very low energy instrumentation, which is one of the criteria, and because our ability to bring things to the market. So for the space launcher, the rocket launcher, we're using our single photon detector as an SPD system, our electronics, the ID900 time controller and ID300 laser. Together that makes a system for the Ariane launcher. Okay, other examples of lab to marketplace, you're probably familiar, some of you are familiar with our SPAD detectors. You can see 4 on a rack in the laboratory, and it takes quite a while to get them into a rack-mounted, telecom-mounted rack. Same thing with the QRNG, which used to be a big box, and now it is just being launched in the Samsung Galaxy Quantum. Okay, few words about our single photon systems. Traditionally, we've been making SPAD, single photon avalanche for the diodes. More recently, the focus has been on superconducting nanowire detectors. We combine it with our timing electronics to provide quantum sensing solutions. And those solutions are both in material science, whether it's fluorescence lifetime, in material science, for example, quantum dots or nitrogen vacancy centers, quantum physics, and quantum communication, which is the core of our business. And of course, there are many other applications too, in automotive, in surveillance and defense, and oil and gas. So SPADs, SNSPDs, and electronics, those are the main areas of our technology. I will go over this, I will skip over the next slides very quickly because we don't have that much time. So the ID221 is a detector that many of you are familiar with. It's a SPAD detector at -50 Geiger mode, very low dark count rate for it. Can go even lower with the same diode if you go use a Stirling engine cooling to -90, and that's what we did. Get down to less than 80 counts per second. The backdraw about SPAD is that they are slow and they have a lower quantum efficiency, single detecting efficiently than nanowires. So in the last few years, we have been focusing on the nanowire detectors, and you can see some of the characters here. We make detectors both optimized for communication wavelength and visual wavelength. We can make them broadband. We've been developing high-speed detectors. PNR, which is photon number resolving detectors, absolute for number, so you can, with 100% certainty, you can tell you whether you have 1, 2, or 3, or 4 photons. And polarization insensitive detectors. The timing device is our ID900. The very nice part about it is an active device, so you have 4 high-speed outputs. So, for example, for a presentation yesterday from Gregory, when he was talking about being able to control the spin, yes, we can do that because we can control with much faster than a microsecond, a few hundred nanoseconds. We can do conditional, based on your inputs, you can have conditional outputs. The next slides, I think I'll pace through it very quickly. It's just an overview of the SNSPD and what the characteristics are. You can check our webinar, in which it's extensively discussed. So it's all based on our ability to make our own wafers and detectors. And based on that, we have very high quality detectors and detection characteristics. So I'm skipping through it so that I won't take any time from Jack. Just want to show you this graph. This is an absolute photon number resolving, which I know some of you are quite interested in doing. We're using it, of course, for our quantum communication system. We have Alice and Bob, and we want to avoid interception by Eve. So right now we can go up to 400 kilometers with the SNSPD system. The whole system is automated, so it's a turnkey. Time controller, 4 high-speed outputs for delay and pattern net generation. That's probably the most important thing for you. And that's the nice thing is you can use it at any level, whether you want to use a graphic user interface, whether you want to do programming in Python or MATLAB or LabVIEW, you can use it. If you want to use Skippy commands, you can use it. It has, on the left-hand side, it has interactive screens to set the parameters, whether it's for the TDC, time to digital converter, or your outputs, your digital to laser generation. And you can have 4-fold coincidences as a 4-fold TDC. The 4th level of interaction is actually, we have provided access to our FPGA through a graphic user interface for a PDF editor. So summary slides. So please go to idquantique.com to look at our webinars, which have a detail of each of the products and their applications. And you can always send an email to info@idquantique. Thank you.
Okay, Rick, thanks very much. If you could turn off sharing, please.
Yep, I'll try.
And Rick is a 2-time sponsor. He sponsored last year and also this year. I thank you very much for your continued sponsorship to be able to bring this kind of material to all our participants.